Hi Geo H, this is Unit 3, Lesson 1, and today we're going to start talking about some proofs. So I'm just reading from the top. The most important book in geometry was written over 2,300 years ago by a man named Euclid. He used pure reason and logic to build most of the plane geometry we study today. His approach, which entails drawing logical inferences from known properties of figures in order to prove other properties, is given the name Euclidean geometry. So basically, you're going to be given a picture or words that is going to be your given, and from that given, you're going to be able to draw other conclusions from it. So we're going to just start off with our exercise 1, which is a midpoint. So in the following diagram, it is given that C is the midpoint of AB. So that midpoint word right there, that's sort of our given. The midpoint of AB. So if C is the midpoint of AB, that means that it's cutting AB in half. And we've talked about this already, but now we're going to start to talk about conclusions more and how we would write that in a proof. But if C is the midpoint, we know that the left half, which is AC, is congruent to the right half, which is CB. The way I write a line segment is I use two letters with that line segment symbol over that. And my symbol for congruent is the equal sign with that little squiggly. Now, why do I know that? I know that because of my definition of midpoint. A midpoint divides a segment into two congruent parts. So that's my reason why. So I'm told it's a midpoint. I know a midpoint divides a segment in half. So I say that the left half equals the right half. And the reason that they are equal is because of my definition of midpoint. It's important that you know the terminology like midpoint and some other words that we've known. So there's a little summary right here of some words that we've already discussed. In addition to midpoint, we've talked about a segment bisector. So a segment bisector is a line, ray, or segment that passes through the midpoint of another segment. So if I have a segment bisector goes through the midpoint. It does the same thing though, and I talked about this before, in that it divides the segment in half, so the conclusion is the same. An angle bisector cuts an angle in half. So if you have an angle, all right, and this line right here cuts it in half, then I can just say that angle 1 is congruent to angle 2. So a segment bisector results in two congruent segments. An angle bisector results in two congruent angles. And then this word perpendicular, which we've of course seen before, and we're going to see it many more times. Perpendicular lines are any two line segments or rays that intersect to form right angles. And the symbol that we use for perpendicular is that upside down T. Okay, so if AB is perpendicular to CD, then they form a right angle. Okay, so we're going to review a little bit of that terminology, and then we're going to add on a few more words, and then we're actually going to try some proofs. So in exercise 2, I have line MBN, so I'm just telling you that MBN is a line, and I know that AB is perpendicular to MN, so that's the big thing right there. We'll go in order. So A, what does the first given MBN tell you? It tells me that those points, MB and N, are collinear. Now, lots of times we just sort of assume that. It's nothing that we really put into our proof. I also know that if I'm talking about an angle, like angle MBN, that would equal 180 degrees. So I have a line, but yet that line also is creating an angle. The big thing that we're going to use over and over again is the perpendicular. So if AB is perpendicular to MN, the first thing I do is AB, I look at AB, that was MN. I look at AB, I look at MN, and I draw that perpendicular symbol in there. Now in this one, I certainly don't have to trace over AB and MN, but if I have a diagram that's a little bit more complicated, you might want to trace the lines that they're telling you so you know where the right angle actually is. But I put my symbol in there to remind me. And then I would say that the angle on the left, which I would call angle MBA, is congruent. Actually, I'm not going to even go that far. The angle on the MBA and angle ABN, the one on the right, are both right angles. you're going to see when we do a proof that once we know that they're right angles, they also have to be congruent to each other. But for right now, we'll just say they're right angles. Okay? Can you conclude that MB, which is this right here on the left, is equal to NB on the right? They look equal, but do I know they're equal? No, I actually don't know they're equal. The reason why I don't know they're equal is because I was not told that AB was bisecting. There was nothing about bisecting. So this is important to remember about proofs. Just because something looks like it's being cut in half, if we are not told that it's a bisector, we can't assume it. If I wasn't told that this was perpendicular, I couldn't assume that that was a right angle. So MB is not equal to MB because we're not told that AB bisects MN. So you can't go by what it looks like. All right, let's look at some more vocabulary on the next page. So I've already mentioned this to you before. We've talked about perpendicular and we've talked about bisectors. Now I'm sort of putting those two words together. So a perpendicular bisector is a line, a ray, or a segment that passes through the midpoint of a segment. That's the bisector part. That passes through the midpoint of a segment and I abbreviate midpoint when I'm writing it, and makes a right angle. So it has two jobs. It's bisecting, which means it's going through the midpoint, and it's also perpendicular, which means it makes a right angle. So it makes a right angle with it. And I actually even talked about a median before. Well, let me draw a picture for the perpendicular bisector. So if I have a segment, so if this is a perpendicular bisector, it's perpendicular and it bisects. A median of a triangle is a line drawn from the vertex of a triangle to the midpoint of the opposite side. And what does that look like? So I have a triangle. It's a line drawn from the vertex to the midpoint of the opposite side. It does the same thing. It cuts that side in half, but it's specifically in a triangle. Does it have to come from the top? It doesn't. And then the altitude of a triangle is a line drawn from a triangle, again drawn from the vertex, a line drawn from the vertex of a triangle, perpendicular to the opposite side. That's my little puppy dog, sorry. The altitude is the height of the triangle. So what does that look like in a picture? So I have a triangle, there's my vertex, and it's drawn perpendicular to that opposite side. So it's going to form a right angle. All right, so let's look at some examples, and then I'm going to show you an actual proof, just easy 1 or 2 step proofs, what they look like though. So in the first one, in exercise 3, ABC is drawn such that D lies on side BC and point E lies on side AC. We're going to read the givens and state any kind of conclusion that I can come up with. So the first thing is I'm bisecting angle ABC. I'm cutting angle ABC in half. All right, so I'm going to go to angle ABC. So start at A, go to B, go to C. So the one that I just traced in red right there. If I'm bisecting the angle, I am cutting the angle in half. The result is going to be I'm going to have some angle congruent to some angle. So basically it's going to be this angle on top, angle ABE. I'll use the 3 letters. You can also put a picture into numbers into your picture. That would be fine. And this angle on the bottom, it's congruent to angle EBD. Okay, so that's the first thing. Now why? When we do an actual proof, we're going to need a reason. And the reason is an angle bisector divides an angle into two congruent angles. So it divides it in half. And then my second thing, which I'll do in a different color, is I have a median. Now a median is a line, and I'll do that down here. A median is a line, so AD is the median. We just defined that up above. If AD is the median, a median is a line drawn from the vertex of a triangle to the midpoint of the opposite side. So I know right now that D is the midpoint. Why do I know that? Because a median divides is a line drawn from the vertex to the midpoint of the opposite side. And if D is the midpoint, I know that BD is congruent to DC. A midpoint divides a segment into two congruent parts. So there are two conclusions I can draw just from that median. So a midpoint divides a segment into two congruent parts. I'm going to ignore that.
Call from 120-277-34373.
Okay. And then exercise 4. I have these two triangles, and we know the following. We know that MW is perpendicular bisector of TN. So you got to be careful which is being bisected. I'm bisecting TN, and it's also perpendicular. So I'm bisecting TN. Go to TN. TN is the thing that's being cut in half. All right, and it's perpendicular. So basically, since it's a bisector, you know that TS, that top half of the line, is congruent to SN, the bottom half. Okay, how do I know that? A bisector divides a segment into two congruent segments, just like the midpoint. A bisector divides a segment into two congruent segments. And it's perpendicular. So since it's perpendicular, these are right angles. And I'll show you how I can just put numbers in there. So I can just say, as long as you do that on your picture, angle 1 and angle 2 are right angles. Why? Because perpendicular lines, and instead of writing that word perpendicular, you can use that symbol. Perpendicular lines form right angles. Then they want to know, is TS an altitude? Well, let's find TS. TS, I'll do in red right here. Is it an altitude? An altitude is a line drawn from a vertex perpendicular to the opposite side. So I would say, yes, it definitely is an altitude. Yes, it's an altitude. An altitude is any segment drawn from the vertex, which it is, perpendicular to opposite side. And you can see any of these abbreviations that I'm doing, you can also do in your proofs, and you're welcome to do on your paper. All right, so I want to show you some actual proofs. So here's how a proof works. So a proof, you have a picture, generally. Sometimes you have to draw your own picture, but not always. You have a given. You're going to write statements on the left, reasons on the right. Every statement has to have a reason. I usually start off with the given. So my given in this picture is that D is the midpoint of AC. So that becomes step 1. Step 1 says D is the midpoint of AC. How do I know that? Because I was told that. That's the given. Now from that statement, you're going to be able to come up with statement 2. So I'm going to go. Now, the interesting thing, I use the same exact picture for each of these, but I change the given each time, so you're going to see that the conclusion is going to be different. If D is the midpoint of AC, so what I do with midpoint, I put a big fat dot on the midpoint, and I mark the two sides congruent to each other. So then I can write that as my statement. AD is congruent to DC. And what's the reason for that? A midpoint divides a segment into two congruent segments. Midpoint divides a segment into two congruent segments. Done. Okay, now I'm going to do, I think 5 of these I have here. In B, I'm changing the given. And B, I am bisecting AC. So BD is bisecting AC. This line BD is cutting AC in half. So if it's cutting it in half, then I can just mark it. Again, it makes D the midpoint. So statement 1 is always my given. BD bisects AC, given. Mark your picture so then you know what to write as your statement. If it's a bisector, it's cutting the segment in half. So I actually have the same statement as I did in the proof above. The reason will be a little bit different though. Instead of using that word midpoint, I'm going to use the word bisector. A bisector divides a segment into two congruent parts. Into two congruent segments. And see how I used the symbol for congruent. That's okay. And this says into. All right, nothing else. I know it looks perpendicular. I cannot say that because that was not part of the given. Now, in C, same picture, but I'm changing the given up. I'm bisecting angle ABC. So let me trace angle ABC. I'm bisecting it. That means I'm cutting it in half. So I'm going to mark them congruent. Angle 1, first of all, I'm going to put angle 1 and angle 2 on my picture. And then I'm going to say that they are congruent to each other. So angle 1 is congruent to angle 2. Now normally you have to write step 1. It's not going to be written for you, but for all these I just wrote the statement. The first statement is just to write the given down. Angle 1 is congruent to angle 2. Why? Because an angle bisector divides an angle into two congruent angles. Into two congruent angles. I'm using a symbol for congruent. I'm using a symbol for angles. So angles, I use a symbol also. I use the number 2 to write the number 2. All right, now this one is important. This comes up many, many, many times. BD is perpendicular to AC. Now, if it's perpendicular to AC, then it makes right angles. So I'm going to put a 1 and a 2 on my picture. And now that I wrote there, it's hard to write my 2. But the first step is I'm going to say that they are right angles. The reason that they're right angles is because perpendicular lines form right angles. Okay, so perpendicular lines, and that was my given, my first statement. BD is perpendicular to AC. Reason given. Now, because of that, I know perpendicular lines form right angles, so that results in statement 2. Angle 1 and angle 2 are right angles. Why? Because perpendicular lines form right angles. Now, I actually have a statement 3. If angle 1 is a right angle and angle 2 is a right angle, that means they're both 90 degrees each, so they are in fact congruent to each other. And the reason that they're congruent is because all right angles are congruent. So when I have this perpendicular line, I get two statements out of it. The first statement is to say that they're right angles, because perpendicular lines form right angles. And the second statement is to say they're congruent because all right angles are congruent. All right. E, same exact picture, but now I'm telling you that BD is the median. If BD is the median, then that makes D the midpoint of AC. Why is it the midpoint of AC? Because the median is line drawn from vertex to midpoint. Okay, so a median makes a midpoint. The first step is just to repeat that given. BD is the median of triangle ABC. The reason given. Now, since it's a median, that makes D the midpoint. D is the midpoint of AC. What's the reason? A median is a line drawn from the vertex to the midpoint. But now I have another key word, midpoint. If D is the midpoint, then that means it's cutting AC in half. So I can say that AD is congruent to DC. Reason? Midpoint divides a segment into two congruent segments. Midpoint divides a segment into two congruent segments. So again, median. Now median doesn't come up as much as perpendicular like the one before, but if I have a median, it gives us two statements to write. A median doesn't make the segments congruent. A median makes a midpoint, and the midpoint makes those two segments congruent. So it's like statement 1 gives you statement 2, and then statement 2 gives you statement 3. And then with the last one, I have an altitude. If BD is the altitude, it's the height of the triangle. It's perpendicular. So the very first thing is the altitude. So statement 1 says that BD is the altitude given. And altitude makes perpendicular lines. So I'm going to say which lines are perpendicular. AC is perpendicular to BD. Altitude is perpendicular to opposite side. Now, perpendicular lines make right angles. So I'm going to call this angle 1 and angle 2. And I'm going to say angle 1 and angle 2 are right angles. The reason, how do I know angle 1 and angle 2 are right angles? Because the step before told me those lines were perpendicular. So angle 1 and angle 2 are right angles because perpendicular lines form right angles. And then if they are right angles, then that means that they are congruent to each other. Angle 1 is congruent to angle 2 because all right angles are congruent. Sorry about that. Okay, so you can see that these steps follow sequentially. The altitude makes perpendicular lines, step 2. Perpendicular lines make right angles.